Hi, welcome to my video on proofs with angle bisector, median, altitude, and perpendicular bisector, part 2. In this video, I'm going to do several proofs with those terms in it. So let's do number 1. Given angle W equals angle Y, okay? We're given that XM is a median of XWY. XM is a median of XWY. Because it's a median, then M is going to be a midpoint, and that means that MW equals MY. So to prove the triangles, I have to show that MX bisects WXY. So MX bisects WXY. If it bisects, then I have to get that these two angles are going to be equal. So I get these two angles equal by doing congruent triangles. So if I mark XM equal to XM, common side, I'll have an ASS, and we cannot prove triangles congruent by ASS. So I notice that these two angles are equal. That means that these two sides are equal, because if two angles of a triangle are equal, then the sides of them are equal. So now I have the triangle congruent by SAS, and I have these two angles equal. So now I have a plan for my proof. So angle W equals angle Y, given. And as a result of those two angles equal, WX equals YX, converse of ITT. And we have XM is a median triangle XWY, given. And as a result, it's a median. A median goes to the midpoint, so M is a midpoint of WY, because a median goes from a vertex to the midpoint of the opposite side. So that's the definition of a median of a triangle. And because it's the midpoint, then we have MW equals MY, and that's the definition of a midpoint. And as a result, we have these sides marked. We have the two sides equal here, two sides equal here. So we have triangle XMW is congruent to triangle XMY. It's an SAS, congruency. And as a result, we have angle 1 equals angle 2 in the two triangles, and that's CPCTC. And because these angles are equal, that means that MX bisects angle WXY. MX bisects WXY, and the reason is definition of angle bisector. So one proof is done. So let's do another proof to see what happens. Again, we have a triangle, and we have different information given. So we have PR is an altitude of the triangle PTS. So PR is an altitude. That means an altitude is perpendicular to the opposite side. And we have, that means that these two angles are equal if we wish to use it. PR bisects angle TPS. If PR bisects this angle here, that means that angle 1 is going to equal angle 2 because of a bisector. And we have to prove that triangle TPS is isosceles. to get an isosceles triangle, we need two sides equal. So how do we get the two sides equal? Well, let's see if we can get a pair of congruent triangles. We have those two angles equal. We can have these two angles equal because they're perpendicular. We can have PR is equal to PR, common side. So the triangles are congruent by ASA. Therefore, these two sides to be equal, CPCTC. So the triangle is isosceles. So again, I have my plan. So here we go. I have PR is an altitude of triangle PTS. And because it's an altitude, that means that PR is perpendicular to TS. Oops, make that an S. Make that as an S. TS. PR is perpendicular to TS, and the reason is definition of an altitude. An altitude leaves the vertex and goes perpendicular to the opposite side. And because those two, because they're perpendicular, that means that angle 3 and angle 4 are right angles. And that's the definition of perpendicular segments or lines. In this case is segments. And, oh, that's number 4. I'm going ahead of myself now. Because angle 3 and angle 4 are right angles, angle 3 equals angle 4. All right angles are equal. All right angles are 90 degrees, so they're all equal. So we got angle 3 equals angle 4. And now we have PR is equal to PR. It's a common side to both triangles. So PRT, PRS, PR is in both triangles. So now I have triangle PRT congruent to triangle. Make that a triangle. Looks like a triangle. PRS, and it's an ASA congruency. And as a result of being congruent, we have PT equals PS, CPCTC. Congruent parts of congruent triangles are congruent, and because they're equal, that means that triangle TPS is isosceles because we have the two sides equal. That's the definition of isosceles triangle. Okay, let's continue. We have a couple of more proofs to do. Now we have, it says here that AT is the perpendicular bisector of BC, and it says because it's the perpendicular bisector, then I can have the triangles worked out to be congruent, or I can say that AB equals AC, because any point on the perpendicular bisector is equal distance from the endpoint of the segment. And also we have AF is the perpendicular bisector of CH, so that means that AC equals AH for the same reason. Any point that's on the perpendicular bisector is equal distance from the endpoint to the segment. It's called a perpendicular bisector theorem. I call it the PBT. And since AB equals AC and AC equals AH, that means AB equals AC, which is what we have to prove here. So we have to prove AB equals AC. So here we go. So AT is the perpendicular bisector of BC. So we have AB equals AC, And I better put the given in here first. Number 2, perpendicular bisector theorem. Again, check with your teacher if you can call it that. Any point that's on the perpendicular bisector. So T is equal distance from B and C because it's on the perpendicular bisector. A is equal distance from B and C because it's on the perpendicular bisector of the segment. And number 3, AF is the perpendicular bisector of CH, and that's a given. And number 4, that means that AC is equal to AH, and again it's perpendicular bisector theorem. Any point that's on the perpendicular bisector is equal distance from the endpoints of the segment that it's cutting into. And as a result, we got AB equals AC, AC equals AH. So AB is equal to AH. And the reason is transitive property of equality. It's a transitive property of equality. Okay, number 4. It says, prove the altitude of an equilateral triangle forms two 30, 60, 90 right triangles. Okay, so it says an equilateral triangle, so I'm going to draw this triangle and label it P, Q, R. And it says the altitude of the right triangle, the equilateral triangle, forms two 30, 60, 90. So let's draw an altitude from P down to an altitude, leaves P and goes perpendicular to QR. So there's an altitude. So we're given, I have to put down my given, I'm given triangle PQR is equilateral. And we're given that, and P is perpendicular, so I'm going to have to name this angle here, or name where it hits. So I'm going to say it hits at T. So this is the altitude is drawn to PQ hitting or intersecting PQ at T. So we have PT is an altitude. And we have to prove that triangle PTQ and triangle PTR are 30, 60, 90. So here we go. So we got a given. How do we do it? Well, we got let's look at the proof before we start to write it up. We got an equilateral triangle, so that means we have a 60-degree angles in the equilateral triangle. So this angle up here is 60, and these are 60s, and we have an altitude, so that makes it a 90 there and there. So if that's and an altitude, notice that all the sides are equal. So PQ equals PR equals QR, because all sides are equal. So that means this altitude is drawn from the vertex angle. So this also is also an angle bisector. So this 60-degree angle is broken up into two angles that are equal because it's bisector 30 and 30. So let's put the proof together. We have triangle PQR is equilateral. Okay, that's a given. All the times I write out givens, I'm still sometimes thinking about how to spell it, whether you believe that or not. So that means I've got an equilateral triangle. That means we have that angle R and angle Q and angle QPR equals 60 degrees. Each angle of an equilateral triangle equals 60 as the previous proof that we did. And so now we have number 3, we have PT is an altitude. Because it's an altitude, that's a given. That means that we have PT is perpendicular to QR. That's definition of an altitude. And as a result, we have, let's name angle 1 and angle 2 here. Angle 1 and angle 2 are right angles. Definition of perpendicular segments. And that means that angle 1 and angle 2 are 90 degrees, and that's the definition of a right angle. A right angle is an angle that measures 90. So we got 60-degree angles, we got 90-degree angles, and as a result, this angle is 60. So that means that PT is an angle bisector because an altitude is an angle bisector when drawn from the vertex angle of an isosceles triangle. And number 8, that means that you bisect, that means that angle, let's name this angle 3 and angle 4. Angle 3 and angle 4 are 30 degrees. Definition of an angle bisector, because the angle is 60, that's bisected at 30 degrees each. That means that we have a 30, 60, 90 and a 30, 60, 90. So triangles PTQ and triangle PTR are 30, 60, 90. Definition of because we just say angles are 30, 60, and 90. There's no definition. We proved that the angles are 30, 60, 90. Okay. And number 5, the last proof to do. Prove if two sides of a triangle are equal, then the angles opposite the equal sides are equal. So this is really proven. This statement is the ITT. So we have to prove the ITT, but we have to do it in another way. So let's draw a triangle. This triangle, and we'll name the triangle as EFG. FH. So we have two sides of a triangle are equal. So let's say that EF equals EH. And we have to prove that angle F equals angle H. So we're given a triangle EFH with EF equal to EH. And we have to prove that the angle F equals the angle H. We're given two sides equal. We have to prove that these angles are equal. And to do that, well, we did all this work on altitudes and medians and perpendicular bisectors. So these two sides are equal. This is the vertex angle. So if I draw an altitude from E down to FH and intersect at P, so this is an altitude drawn down here, then remember, because it's an altitude, we have perpendicular lines, we have these equal, so we have these angles equal. We have this angle here, oh, we can't say this, so this is angle 1 going to equal angle 2. But how do we get these angles equal? So we have an altitude makes a right angle. We have this side is the common side, EP, but we can't say that these angles are equal here because you'll have an ASS. So what we have to do is say we have a pair of right triangles because this is an H and an L. So we have to do it with an HL proof to get the two angles 2 and 3 equal. Oh, that's 2. That's angle 2, angle 1, and angle 2. So here we go. We have EF equals EH given. So what I have to do now is draw an altitude from angle E to intersect FH at P. That's what we call a construction. I'm allowed to do that. And as a result, that's an altitude. So that means that EP is perpendicular to FH. Definition of an altitude. And that means that, let's name angle 3 and angle 4. Angle 3 and angle 4 are right angles. That's definition of perpendicular segments or lines. And as a result, now we said we can't say these are equal, but it won't do anything because if we say these are equal, then we'll have an ASS and we can't prove triangles congruent. So we have to say that triangle EPF and triangle EPH are right triangles. Definition of right triangles. And now we have to say that EP equals EP, common side, to the triangles. So now we have this side equal in each. This is the common side. These are the right angles. And so we have a right triangle. So that means the triangle EPF is congruent to triangle EPH. by hypotenuse leg. Because we have a pair of right triangles with the hypotenuse equal and our legs equal, therefore the triangles are congruent by HL. And that makes angle F equal to angle H by CPCTC. And again, we cannot prove triangles congruent by ASS, so we have to go with a pair of congruent triangles here in order to get. Remember, if these two sides are equal, then these angles are equal. But since we're proving this proof, we have to go in a roundabout way. We can't just make the statement and say it's done. We have to prove it another way. So that brings us to the end of the video on perpendicular bisectors and medians and altitudes and angle bisectors. And that's the second video. And if you liked the video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you very much. Bye-bye.